Just having to look up.
Yeah.
That's why we need you.
If I can push the button here, so when you get to your stage, maybe you can just use the mouse. It's easier.
No, start us early and then people can join and we can start off. Yeah.
Okay, we started, so everyone else.
I'm quite interested to see the questions that we get, and hoping we're getting a few interesting ones that we weren't ready for. Those are actually quite a lot. Right, good morning, everyone. Welcome to our InFocus webinar today. So today we'll be looking at a few predictive resilience topics. How are we going to be able to start looking at working with holistic digital twins by the use of BIM data as well as GIS data? So my name is Jason Grieve. I'm the current civil specialist, technology specialist here at Modena AEC, and today I've got Claudia with me. Welcome.
Thank you.
All right, so we're going to start off just with a few housekeepings. So today's webinar will be recorded, so you'll have access to that and be sent to you at a later stage. Now, through the course of this webinar, please feel free to ask us questions within the questions Q&A window down below. It will be fantastic to get that feedback from you guys. We're trying to make this a nice interactive session today, so please join us. Then we would love your feedback at the end. Once again, we are always trying to improve these webinars year by year. So please let us know how we can improve and make this better for your experience next time. So today we are going to be looking at the unifying BIM and GIS with the intent on the topic of water infrastructure. So I'm just going to let Claudia introduce himself before we continue, and then we'll get started.
Good morning, everyone. My name is Claudio Duarte, so working for a technology company called Esri South Africa, and we specialize in geospatial geography. So essentially, through our software consultancy service, etc., we help organizations make better decisions through the power of location intelligence. Thank you for having me.
It's a big pleasure. We're quite excited to have you. It's so exciting to see the industry moving into a collaborative space and no more working as competition, you know. It's really so nice. So getting started throughout today's session. So I want us to start understanding where are we currently in the space of our water asset life cycle, as well as the age of these. So I'm sure a lot of us are aware that South Africa's water infrastructure is currently in a critical state. And I want us to start looking at how can we start, firstly, fixing the old problems that are currently facing, as well as then how can we start being preemptive in finding solutions that will arise in the future. And then I'm going to start showing us how we're actually working with these new tools. So today we'll be looking at software like InfoWater Pro that is built into ArcGIS, as well as then GeoBIM and some other points that just allow us to start understanding how are we applying design model elements with metadata and applying that into a geospatial context. Because we are currently seeing that when we go from design over to operation, that is the biggest gap that the market is currently facing. So then we have critical roles of geodetic accuracy within infrastructures. So Claudia will be touching on those, as well as then a few practical applications on how we're actually connecting the Autodesk world to the Esri world. All right, so we're going to put up a poll, and I want us to start with a bit of an interactive session. Now, when we work with digital twins over to operations, we currently see a lot of bottlenecks. So I've got a few questions or a few options on screen where I want to start seeing where do you currently face the most friction during a water infrastructure project. So is it due to inaccurate outdated site content, clash detection or coordination with regards to other disciplines or other partners on the project? Data loss or rework when we go over through to construction, because there we lose dynamic model control and we move over to a more paper-based system. And then the last one is lack of visibility during the operations and maintenance phase. So do the people that manage operation and maintenance have the information that is required? So I just want to leave that on screen for a minute or two and let's see what everyone thinks. Now, I just want to pop a question to Claudia. Out of your experience, what would be your selection?
I think option C is quite a relevant one. And most of the time, it's actually through data exchange, through converting from one system to another. There's this concept called data degradation. So there's usually a lot of data loss just to kind of make it fit the container of this other system from where it didn't originate from. And that's one part. Then obviously, the second part, if it's not digitized, there's a lot of data lost. It's on some random USB or filing cabinet or whatever the case is. So I think definitely option C is how do we, that collaborative effort, that which you have paid for to collect information for someone to actually design for you, etc., etc. How do you keep that within the whole project delivery lifecycle?
Fantastic. Yeah, no, that's a big one. Now, I think out of my experience from the design point of view, that would be option B, would kind of be my clash detection. I've actually had a perfect example in the beginning of my career. We were working on a massive fresh produce market. And we had a stage where we had some pillars, obviously for the foundation of the structure and stuff like that. And then we had a basement ramp going through this. And where the single basement pillar was placed, we hadn't actually confirmed that the levels of the culvert that was going below that were actually correct. So when the guys actually got to site and were busy constructing, they realized that this massive 1.5 meter culvert was halfway going into the basement. So we had a clash detection there between the structural guys and the stormwater guys. So that was quite a big one. All right. Fantastic. All right, so I think we can close the poll from there. And I think we'll just keep the poll running and we'll continue further. There we go. Fantastic. So when we look at these critical elements that I've mentioned earlier, let's start being a little bit more specific and look at specific problems that we're working with. So currently at the moment, we look at severe water scarcity. So that is just coming from an environmental point of view. So just some fun facts that currently South Africa is in the top 30 driest countries in the world globally. Compared to the world average, we're pretty much behind on about 40% of our water rainfall that we receive. So the management of this water is first off the most critical element. And then from there, we've got aging infrastructure. Now, the aging infrastructure is a large problem, especially within our modern times, because we haven't really been maintaining these elements that are so far kilometers into the bush with access to, firstly, maintenance checks of making sure that these things are even functioning correctly. And majority of the times you only know about the problem because of a larger break in the system closer to a city or nice municipality. Now, quite recently, I was going through LinkedIn at a stage, and I saw that there's a municipality nearby, just southeast of Kempton Park and Benoni, Lesedi municipality. And recently, they have actually been reduced. Their bulk water feed line has been reduced by 20% by Rand Water due to the fact of non-compliance on payment schedules. So this was something that when I read this, it was so shocking because people are now losing access to a basic need due to the mismanagement of other people. And small software changes, such as InfoWater Pro, will allow us to manage these more efficiently. because InfoWater Pro allows us to measure each household's offtake of the system. And within the larger master planning, we can then identify where these shortfalls are coming from. So should we have non-compliance on payment from certain users, we can then identify where are we limiting the access to, because we are keeping everyone accountable to that. So then from there, we move over to a little bit more of further environmental factors, such as our extreme weather. So we all know global warming is a thing, and it's been affecting us for multiple different years. And once again, we're just seeing the repercussions of that. I mean, we all can currently see our weather patterns are totally out of whack. Our summers versus our winters. When are we receiving rain? The intensity of the rain, it's just up and down all over. And then with regards to the data silos, this is, I think, a whole industry identification of it being a problem. And what I actually want to focus on with regards to data silos is the disconnected digital workflows, because that is the main problem or the biggest fix that we can apply at this stage. If we are able to preemptively understand what everyone through the entire life cycle of the project is going to need, that allows us to cater for that in the beginning. And that will allow us to start understanding, because each discipline or each phase of a project is seen as their own responsibility. That is where these data silos end up being. And if we can be a little bit more agnostic and allowing of other disciplines to have a say in what we do, that allows the digital twin to finalize to the end answer a lot faster than what everyone normally expects, because people can put in their inputs way earlier than what is normally expected. So that allows us to be preemptive on that and be ready when we need that information. And this is where we'll start understanding the difference between the model-based elements and a geo-based element, and what is metadata for each of these assigned. So I think our site boundary is majority of the time the largest differentiator between an internal and external element. So inside the fence, that is where we will have majority of the stakeholders with regards to digital investment and creation and planning, where it be this architect with his building, the structural engineer doing load calculations off of his model, the civil engineer with his road geometric layout or his wet services. All of these play a fact. And once again, this is where we can start seeing those silos, the architect, the structural versus civil. And if we can start understanding to incorporate all disciplines within that design phase, when we move outside the fence to geolocation and metadata, we have access to that already. We don't need to go back and do the amount of rework and recreate that. And then with regards to outside the fence, this is where we'll now start understanding what is the type of metadata we need. With regards to invert elevations, are we working with specific pressure zones within a certain municipality or master plan? Are there any limitations that may be faced on one site compared to another? Because when we move outside of the site, everything starts connecting to each other. And it's very difficult for us to understand the impact that one municipality has on the other. So this will allow us to start bridging past our site and understanding the bigger picture. So understanding the function between inside your site and outside of the site. So for a successful digital twin, we need to understand from the designer's point of view what the field is going to need. So anything such as your material classes, your invert levels, and your installation depths, that's elements such as knowing what to replace, where to replace it, and when to replace it. Because if I have this beforehand, I can build a plan to give me the answer of that. I can be preemptive when looking at that. And then when we go over to the field engineer needs a single source of truth. It doesn't help that he's getting coordinate systems for the road geometric layout from the civil engineer and the architect's giving him foundation footing layout points, but the civil engineer and the architect haven't even spoken to each other. And that is where we get this clash. So making sure that direct design intent and integrity is incorporated. So using elements such as ArcGIS Pro as well as Civil 3D with InfoWater Pro is what allows us to bridge those gaps. This is what allows us to streamline the communication flow. And before we even get to site, where we have machines and trenches and laborers on site, we can spot that problem beforehand. And in order for us to do that, georeferencing is the key. If I don't know where I'm working and what object is relative to its partner, that puts everything out of context. And that's where everyone just gets so confused because no one knows what needs to happen next. There's a problem, I cannot fix it, and that's just where it spirals down. And because is such a key role into this, Esri have also seen that the market needs something more user-friendly and streamlined. And that is where we start working with elements such as GeoBIM, because that gives the modelers a environment that is familiar to them to bridge the geolocation gap. So by simple import-export workflow that has now been created for this purpose, that just streamlines that communication field from the beginning. Now, this is just a short little breakdown of what are the main critical elements when we look at a digital twin. So you'll see we've got our primary functions, spatial scaling, life cycle focus, and then the data output. So what are we looking to achieve when we take a design model or a geolocated model, and what is its purpose? What is it functioning? Who are we serving? So with the primary functions, we can see that for a BIM, it's the what and the how. So what are we building and how is it going to function? And then from there, we'll move over to the GIS to say, where is this on the local planet and why is it even there? What is the bigger purpose of its function within the global economy or within the country itself? So we can see that with the spatial scaling, BIM is a lot more micro. We are smaller scale. We're working to the millimeter. We're working to the third decimal point, whereby with GIS, yes, we can be accurate to the third decimal point, should it be required. But in a larger context of understanding things, I don't need to understand to the millimeter that that pipe is placed at that location. If it's within 50 to 100 centimeters, that's okay, because it still gives me context of the larger plan. And then we can also see with the life cycle focus, what are we planning on focusing on? What is our responsibility as a deliverable at the end of this? So let's start looking at a few examples of how are we actually going to start bridging this gap? Because we're going from the connected data environment, whether that be within ArcGIS Pro, Autodesk Forma, also known as Autodesk Construction Cloud, formerly, as well as then small efficiencies with workflows such as zero duplication, understanding where I have stored data and understanding that I have the controls to extract that when I need it and insert it into a new location where needed. So making sure that your CDE or your central data environment is freely accessible and to an extent open source, where you have the available options to export to the formats that are required. And with Autodesk Forma, quite recently, we've got something quite new with the desktop connector is the data exchanger. So when you're working between Autodesk applications, for example, Civil 3D, Rivet, those allow us to then streamline the workflow of uploading multiple files that are connected between one another. Your DREFs, your XREFs, your data shortcuts, those type of controls. And then because we are doing that, we have access to ArcGIS Pro with the plugins into Civil 3D or InfoWater Pro, and that then brings us back into the macro scale of the digital twin. So here I just have a short case study. This is part of one of our international clients, Arcadis, and I'm just going to play the short video just to have you guys understand the full capability that InfoWater has in our ArcGIS workspace.
So just share again, see when you say share, the audio is not muted. Share with it.
Thank you for that, ladies and gents.
Arcadis is a global engineering firm. We deal with all aspects of the natural and built environment, and that encompasses the entire water cycle from ocean flooding to treatment plants as well as conveyance. We work with a lot of utilities throughout the US. For a lot of them, we're looking at resolving various problems that these utilities face and planning for future growth, and modeling is a tool to solve those issues. InfoWater Pro is one of the main tools that we use for modeling. A lot of utilities are using it out there to not only manage the model, but then also predict into the future. It's a pretty powerful interface, but it's also well organized and simplified. GIS is a critical component of building these models. InfoWater Pro is built inside ArcGIS Pro. So you get that full suite of modeling tools and that GIS integration. You have the power of both inside one platform. There was a large utility in California that we worked with to build models. We took the model results and actually published it for every hydrant into field maps. And since all of the GIS attributes from the hydrant locations are in the model, we can plan for those specific hydrant locations out in the field. They're linked to the model, and that's also linked to those field crews that are actually going out and testing those hydrants. And so it completes a well-defined cycle and benefits a lot of different aspects of the utility. Since InfoWater Pro is inside GIS, we're able to look at and use background information about anticipated redevelopment projects throughout the system. Once we are able to run the model, look at those future conditions, we can easily see exactly where the issues are, and then communicating that to stakeholders so that we can create a master plan for the next 20 years for the system and where we need to focus those capital improvements to have the most impact. The big focus of us moving forward is just making sure that processes are well maintained, improved, and then helping utilities moving forward to support and update those models.
Fantastic. So the nice thing that I wanted to showcase in this video is how Arcadis is able to, once again, future-proof and look at what is the industry doing, what is needed, because they noticed there was a larger problem with future planning and master planning, whereby these new developments would come up and need to connect to existing bulk feed, but the system wasn't ready for it. The initial creators, when they were creating it the first time, were not planning for that and did not know that this would be happening. So they built to their system and to their standards. So that is what we need to keep into account. So with regards to the precision modeling within AEC, you saw a cool few features with regards to fire hydrant flushing and testing and getting those things sorted. So I thought I'd start showing you a few cool tools that are available in InfoWater Pro that aren't normally found within your standard Civil 3D, Civil Designers, and current available design tools. So with regards to InfoWater Pro, like it's been mentioned, we work within a GIS environment. InfoWater Pro is a plugin into ArcGIS Pro. So being able to see live data from whether it's your network specifically, as well as surrounding data for buildings, blocks, foot traffic, user time series patterns, all of those type of things. We can then load that into ArcGIS, which then creates this holistic environment where whether it's geodetically or within a hydraulic parameter, we understand that we have access to that information. So you'll see we can do anything like flush and water quality analysis. So the flushing, like the fire hydrants, making sure that we get any debris or siltation out of the system, and that can be planned for through the use of InfoWater Pro, where we can say, all right, it takes a design team or a field team 20 minutes to flush a single hydrant, and this will then go through into that. We then have additional elements like surge analysis and our fire flow analysis, and surge analysis is something quite unique. Sorry, I see we have a question in the chat. What is surge analysis? So surge analysis is pretty much just the American phrase for water hammer. So here in South Africa, we just call it water hammer. And this is something that a majority of the EpiSwim and EpiNet engines cannot analyze for. So this is just to make sure that our thrust blocks on our bends are large enough. So just to explain in a bit more detail, surge analysis with the water hammer is pretty much when you open and close a pipe too fast. Sometimes, or majority of times, it can form a vacuum or it forms a high pressure zone. And then as that flows through the system, as you have a change in direction, that large increased pressure normally can either decouple fittings or elements, equipment, such as isolating valves or so forth, or even just simply remove the connection out of the thrust block itself. So we can then analyze for those peaks. And then fire flow analysis, should we then have 20, 30 fire hydrants within a master plan, instead of running 30 different simulations or analyses, we can then run those simultaneously within one analysis and still identify each fire hydrant's hydraulic parameters and pressures from there. So this is just having a look at the surge analysis. We were mentioning the replication of water hammer. So this allows us to design and include protection devices. So once we see a surge event taking place in our system, we can now start understanding where do we want to maybe insert additional tanks to control the pressure difference into that, or are we including any PRVs or control mechanisms into that system to maybe preemptively manage so that should there come any surges at a later stage, the system can account and adapt and absorb those differences. And then the surge analysis portion of it, we can include contamination. So should we have root ingress that now has broken up a pipe, we can then start calculating the filtration rate of that siltation through the system. So this is just a small example where we want to show that even just using a simulation of a pump trip is able to be run within the InfoWater Pro analysis, because we're able to analyze for surge, we can recreate or mimic surge events. So should we then run multiple different scenarios, once again, understanding my system holistically in the future understands how I react to it. So if I have the time to be able to take data from site and historic data to say this is normally happening on a weekly occurrence, I can simulate that occurrence preemptively into the system, and I can then start pre-planning, all right, within the next month or so, within my budget restraints, I can build a water tower, or for now, I can only insert 2 PRVs at key locations. And because I have those limitations, I can make the most of what I have available to me. With budget limitations, I can understand that the system needs them at specific points, and that just allows me to design holistically over a longer time period. Now, we can also start dynamically modeling or real-time modeling with the use of SCADA data. So with the use of Info360 Asset, that is a middleman that allows us to take live sensor data on site, which normally gets provided to us in a CSV format. That then gets pushed to Info360 Assets, and that is then what plugs into the design software directly into ArcGIS's InfoWater Pro plugin. And this will allow us to, in real time, see what the system is doing and compare it to our predictions. And the more time we have access to SCADA data, that will allow us to manipulate the preemptive model to get us close to that real world condition. And as soon as we have enough data to design to that real world condition, that now has a one-to-one relation. So should anything real world happen, we can directly assess and prepare from there. So we have another question here. How is the telemetry data shared and processed real time? Fantastic. So yes, like I just said, so that would be the use of a SCADA system with the use of either an Oracle server, a SQL server, or anything like that. So the sensor itself would then go directly linked to the SQL server, and that is where it then places its values that it then measures. Then the Oracle server or SQL server then builds that compound CSV or compressed CSV, and the CSV then gets loaded through Info Assets. And because we have a timestamp of each measurement, we can then assign that into the time series of the analysis. Great. So once again, I just want to show you a few examples of how you can see all of these design control parameters are done within a GIS environment. So we can see, because we are working within ArcGIS Pro, that allows us to directly publish to our online web maps into the ArcGIS Online platform. So from here, we'll now move over to the outside of the fence. And I think Claudio, this is your expertise. I'll hand it over to the expert.
Great. Thank you, Jason. All right. Good morning once again, everyone. Yeah, so I think it's a very exciting discussion, and maybe just to echo Jason's sentiment, right? There's a great positioning for both. BIM gives you the content, and you need it to that high level of accuracy, engineering grade, obviously. But where the GIS fits in, where there's that synergies, where does that content fit within the greater context, right? How is one thing related to another? So that is what we usually call a common operating picture, right? And whether it's at a design stage, a planning stage, wherever it is along the life cycle, what is that common picture to relate all of these different things? And specifically, I want to show you some of these views of, how do we leverage these collated images, if you want to call it, or collated pieces of information in one view, right? Because from that, you can answer different questions for different personas, but it's meant to give you an informed way of making better decisions within your everyday practice, right? So moving away from one of the biggest pain points in industry, and this is global, right? Not only in South Africa, is how do we form what we call a single source of truth? So that's kind of where ISO 19650 came about, right? How do we create a common data environment that, yes, you cater for what you need to, but to ensure that down the line, what you generated can be well used, maintained, and further enriched for its purpose, and so on and so forth until the end. So this is some of the parts and use cases. I'm going to make it quite practical, give you some actual use of this common picture. But one big part is obviously, first and foremost, how do we place this, especially if you at a municipality level or anything like that, where you very much focus on the operations and use. The going saying is, every problem has a location, right? It's where first. A customer calls in where, right? Related to what asset? How is that related upstream, downstream, et cetera, et cetera. And then the real way comes, okay, this is the asset and the certain valve, shutter valve, whatever. Where's the documentation?
Oh, yeah.
Right? That's also another key thing that they need to bring about. And then towards the end, I'll also just open up a little bit of, obviously in this day and age of big data, AI, how are we accumulating and collating all these massive data sets, right? Just moving into more of a predictive state, which is quite interesting. So I'm going to kind of show you two most popular pathways, if you want to call it, to create this integrated visualization. So a nice way that I once heard, I just can't remember who said it, but I'll just put it as anonymous for today. But he kind of just discussed it as, and I'll show you that now, GeoBIM being the orchestrator, right? You've got someone, each one's playing their own instrument, but together, how do you create and bring together a common sound, right? So I will still be the guy at the back with the triangle, maybe, I don't know, that's my music skills at the moment, but it's still important, right? I'm contributing a sound, but how do we coordinate that sound so that we get a common output?
A nice melody.
Yeah, exactly. So the first part I want to show you is how you can interact with, obviously, from the plan design. This is where you've got your Autodesk products, your BIM models, etc. ArcGIS Pro has the interoperability to view it, but not ready to curate it, right? Again, it's fit for purpose. It's coexisting together, so that there's a synergy. And there's actually a technology partnership that was established 10 years ago. So they decided industry is spending way too much time and money importing, exporting, transforming data to get it to fit. Why don't we just work on a way of literally referencing and translating what is already there, right? So curating it in its form that it is, letting it be housed where it is, but now how do we bring that link together? So we can just rather reference. I think that's a big thing.
No need to duplicate.
Exactly, right? So the first part is that, right, you can follow that pathway if you've got this highly detailed information, still bring it into the greater geospatial view, and ArcGIS Pro is the desktop experience for doing that, which you can do with the web or mobile as well. But the other part we're going to focus on a bit more today is a pathway two, right? Where in the geographical view, kind of the spatial view, you will see kind of the asset very simplistically, right? It could be from a simple block to, it doesn't really look like the actual ins and outs to the nth degree. But again, that resides, shows you where it falls in the greater landscape, in the treatment plant, whatever it is. And this is a view of ArcGIS GeoBIM, right? So on the left-hand side, I would have just managed where are my plants, my capital projects, etc. And that is housed in the GIS, the Geographic Information System. That then connects to your Autodesk Forward, right, or Construction Cloud, as it was called previously. But again, you've got two documents that are stored in their own repositories, and you create a link to them.
Fantastic.
So that is what we've seen here, right? So the moment I selected on the left-hand side one of my certain assets, because I created a reference to say, this asset actually has this technical drawing or this BIM model or whatever it is. And now you can get that operable view between the two. So where this mainly helps is more towards the end, maybe for project delivery, but for operations and use. Because a lot of the time you can see this as a spatial reality for document management, right? Or at least discovery. Because if I know that where's a certain asset, where it's related in real life, or at least the name of it, can I quickly create a catalog of it, quickly search for it, get a whole inventory, whether it's the PDFs, whether it's the specification documents, whether it's the actual BIM or, Rivet file, whatever the case is, then you've got access to all of that in one. So it's kind of, again, using the orchestra metaphor, bringing it together, right?
It also helps in the sense of, if I need to have information to answer a question that I'm currently facing, I have access to that. I don't have to be digging for 2 days to go, where did I save the PDF? So that's another fantastic thing.
Yeah, definitely. Yeah, so the realistic way to get this out is, yes, there will be some time spent to reference it, right? To say, this document belongs to this asset, this document belongs to this asset. But that amount of work you put in just to create that link, because again, you're not transforming the original files, you're not trying to take them from one system, put in another. You're just taking what is already existing in one repository from another repository, creating the link, and that's then what you leverage and benefit from this consolidated viewer, right? And to your point, so if you are tasked now with re-engineering one of the parts or seeing how you can optimize it, whatever the case, you want to see what the original drawings look like, or whatever, you can, and I'll show you in later examples, how do we bring in our operational information? What does the maintenance log look like for certain components?
Oh, yes, that's true. Yeah. I mean, how often are we checking that?
Yeah, exactly. Yes. So now how do we get a more enriched picture to make a better decision? So yes, it had a life cycle of 10 years, but based on the maintenance logs, I can see we've done X amount of work. Is it going to be longer than that, shorter than that?
Right, that's true, yes.
That will then fall into OPEX, CAPEX decisions that you need to do for maintenance and etc. Right, so I'm not going to focus too much on how it is, but this is what I was kind of describing, right? You've got two different repositories, one being the GIS, right? It's just called ArcGIS Online, which is a cloud-hosted instance where you put all your data, your maps, your apps. And the other one is obviously from Autodesk, right? Where you now, what you mentioned, the data exchange tool, where you can push whatever files you were generating, design files, etc. You put that into a repository, a folder, right? How do we ensure that these two different folders that are actually describing the same scenario link and get viewed together? So that's, in a nutshell, what ArcGIS GeoBIM brings together, right? It's bringing that synergy between the two. And with that, obviously, how you push and pull into those repositories, there's actually a longer list than this. Yeah. But I just wanted to mention some of the most popular ones, right? It's not limited to just one of the certain products that you might be using in your everyday work, right?
Yeah, they've included the entire Autodesk environment,
precisely,
ecosystem.
And same thing from the ArcGIS side, because we know from a plan design, right, there's a different fit for Autodesk. But how do we collaborate and leverage this information, right? I think that's a key thing. All right, so I'm just going to quickly just maybe look at the questions before we move on to the next slide. So, Jason, I'll let you take the first one. I'll take the second one.
All right. So we've got the first question. Can InForwater Pro simulate dam or spillway breaks? So no, at the moment, unfortunately, none of the Autodesk products are able to assist with that, just due to the fact that it cannot compute the non-Newtonian fluid calculation. That is the only limitation. We are able to adjust viscosity levels of these fluids in these calculations, but a true spillway or dam break, unfortunately not, no.
Yeah, so on that, one thing we can check out, you can just search for it as well. ArcGIS Pro that's the desktop product from Esri, did come up with a flood simulator, right? So you can even say the amount of rainfall or X amount of rate over this amount of time. You can choose where you're going to simulate and put a dam break. We've done it. We've flooded our Mauritius office quite a few times.
Oh, fantastic.
That's on the bus. But yeah, just to see what happens, right? So maybe just see fit for purpose, but you can just search for ArcGIS Pro Flood Simulator. You can
That's
see that.
fantastic. Yeah, that's good. Thanks. Yeah, I don't even know about that.
Yeah, great. All right. And the second question I'll take, how are young designers able to upskill and learn more about GIS and coordinate systems for project coordination? Right. So I think your first stop shop is going to be just search for Esri South Africa. We actually have a college in
fantastic.
Southern Africa that offers the ability to do short courses, or there's actually a lot of free, what we call
wow.
e-learning courses as
Yeah.
well available from Esri. But I think the best way is even just to have the conversation with our college, right? The Esri College. So you can actually say, this is my intended gap that I want to find out. And what do I actually want to do with this, right? Because a lot of times that's how we bridge the gap. And we've seen the synergy as well with Modena, you know, it's how do we bring those two together, right? So yes, and you just search for Esri on, there's a lot of free courses. I think our e-learning currently at the moment is over 1,000 courses that you just can create a profile and you can then
That's fantastic.
access some of them. There's webinars, there's tutorials, there's whole MOOCs, massive online
Yes.
open courses as well. That
I've even attended some of your events you guys host at the office. I know there was actually quite recently a geospatial webinar or event you guys hosted at the office.
Yeah.
So I think you guys just keep an eye on the Esri website, get in contact with the communication line, and just keep up to date with their posts. I'm pretty sure you'll find something there.
Yeah, definitely. All right, so I'm going to jump into some of the next examples, but just to kind of position where we're seeing the actual adoption and use within the GIS, right? The geographical, the spatial richness, once you've orchestrated all this information. And it's definitely on the operate and optimize. So yes, there will always be a place for it on planning, because planning starts with where.
Here we go.
Right? Who is it for? How much? Maybe, and all those different things. But once it's gone through the sophisticated products that need to go, the engineering grade design, et cetera, it's moved along, it's got approved. Yeah. There's going to be a construction phase as well. And obviously data flow throughout these life cycle that looks simple. How do we make sure that that which was designed and generated flows to the next that it can be used, right? But the use case I'm going to show you today is actually speaking around more the operate and optimize, right? So once you have this complete picture, what can you do with it? All right, so what we have here is, again, keeping the idea that the GIS gives you the macro lens to see that of the micro, right? Coming out of BIM and etc. So this organization that's created and a common operating picture, if you want to call it that, to see, number one, can I discover where my assets are, right? For my treatment plant, as an example. And this is where obviously the BIM information is much, much needed, because we need to inherit and bring it in.
There we go, yes.
But they've taken it a bit further. They've created almost a view to say, great, what does my asset health look like? Right?
Oh, yes.
So from a maintenance and operations point of view, they're actually using this common interface to coordinate that type of work, right? To send out these work orders. So kind of coordinating from field to office or office to field, because it's actually both ways.
Correct.
Yeah. So some of the parts you'll see, you know, is like example, they're just tracking how many inspections have been done on certain parts of their assets. What were those results that came back, right?
Yes.
What was the inspection index or grade or health status that they called it? So there is a mobile application, which is kind of just a smartphone, right? So okay. Imagine Jason at the control center, he issues a inspection order to me. He will state status on this specific asset. I can then go to that asset, right? Navigate to that asset, but then I'll open up the smart form of it.
Correct.
Because that's also a big gap we're seeing in the operations side is, yes, headquarters or the office, so to speak, has everything, can have everything collated in a common picture. How is it communicated? Number one, but how do we feed back that information?
Yes.
Because especially in South African context, we've seen a lot of times having just that feedback loop. You can ensure, although I send Jason to go inspect, he gets to the pump, he also has the same view that I'm seeing. He can be like, but wait a minute, standing right here, this structure is not documented, I can see.
Yes.
Right. So not only can he do the inspection, but can he feed back to enrich our digital twin? That's a real big gap, because a lot of times what was designed, built, and actually then becomes your common operating picture is not the same.
That's so true.
There is an
Yeah.
alignment.
And then head office make choices based on what they think they have.
Yeah.
Meanwhile, it's on site, it's two different pictures.
Exactly.
Wow.
And, think of the 2 a.m. scenario, like maybe it's not on a treatment plant, but if there's a water outage, right? How do you document that work that was done?
True.
A lot of times done paper-based, ends up on someone's desk.
WhatsApp.
Yeah, right. And even if it is done through those kind of channels, how does someone then at least document and digitize that? Because it needs to live past the life of the institution.
Correct.
Right. So these are some of the thematic, what we call thematic. You can choose how you want to symbolize what your assets look like, right? So let's just say I've done an inspection on all my assets, and I've given them, and you can see from because it's a visual picture, green usually means good, right? Orange is in between, and red is like there's something poor, or it's going to need to do something.
We've got concern there, yeah.
So this, again, being a collaborative tool, how do you communicate better for decision making? Because this already, if I had to look at this in a flat spreadsheet, right, I could have had a column that maybe said good, bad, poor, whatever. But visually, this already brings my attention forward and it creates a good discussion point. Because then we can go further, right? If we have to replace that, how much is it going to cost, etc. All those different.
Yeah, what sort of the delays,
yeah,
inputs.
Exactly. And towards the bottom, you can see just also tracking kind of KPIs,
I was wondering
how many inspections were done, by who, how often. So there's that accountability because it's made systematic.
Correct.
Right? So again, once a inspection order has been issued, this is actually just one of our other applications helps you with wayfinding, right? Some of these plants might be massive, some of them might be small. Some of them might not even be inside the plant. It's just from, I'm sitting at the headquarters, I have to drive out. Can I do wayfinding more efficiently? So a lot of time your OPEX expenditure is quite high because I'm number one, not driving them on the most optimal route, or I'm not seeing I've got 3 work orders. I should rather change the order in which I address them because it doesn't make sense to drive 10 kilometers there, 20 kilometers there.
Correct, yeah.
Right? I can rather do it in a ring. So that, just like how you use your navigation apps to how to get to work and etc., it's bringing in different data sets to say this is our road, it's our traffic feed, right? This is what's been reported, and then from that location intelligence helps you make a better decision. I'm going to leave right now. I'm going to leave half an hour, right? So same thing on operational front. Once you've issued that order from even their mobile device, they can then use in whatever native application is there to navigate to it, because that's a big part.
A common daily experience would just be able to put that in builders, please. If I need to go find the right paintbrush or the right drill size, just where do I go?
I'll take that pitch. That's good. Yeah. Yeah, definitely. And then again, because you've collated all this information, not only is it a visual to see, but you can actually then see that's metadata, right? You'll see on the right hand side, I've selected over here this tank, and you can see then what is it, right? So from inspection metadata to its actual diameters, manufacturer, etc. If you've captured, and that's obviously where the integrity of what you captured is very important.
Yes.
And a lot of times, and that's a realistic impression, is once you create this common operating picture, you realize what you don't have.
There we go. Yes.
And then great. Now you've got the tools you can enrich your data set to get a more complete picture.
Yes.
Right? Okay, so again, they're using this as a common interface. If we scroll down, they even put their operational drawings there, right? So to create a link to the documents. What they also did is, because you can select the individual components on your network, they allowed you then, speaking to the operations and use, can I create an inspection or work order? It already will assign it then to that specific asset.
Fantastic.
Right? It's just giving them a common control center, if you want to call it, or control view, to, instead of opening this and opening that, it's just all consolidated.
No, so if I'm working in one environment, anything that is associated to that pump is available to me to access in that space.
Correct. And as an organization, you choose what it is that people see and what they can contribute and
engage with,
alter and edit, right?
Okay.
As well. So I think that's quite important. Okay, so we'll open up for Q&A after this one. But again, so the GIS doesn't provide a SCADA, but all it is, because this is actually a web map, right?
Okay.
No installation. It's just you open up your browser.
Oh, so stakeholders also have direct access to this
web application that is being served out from the GIS. And again, because it's orchestrating with the likes of the GeoVim, with the construction cloud, with whatever is housed in your geographic information systems repository. And that's why single source of truth is important. Again, you can leverage, because it's web-centric, if you did have a web viewer already for your SCADA, as an example, if you just want to embed that within the same view. So now you can see, if I was driving this, I would just, click on treatment plant or 2D map. What is it that I want to see?
Correct.
Because different personas, different views are on the same set of assets or the same network or infrastructure, but there's different parts I want to get from it and give to it. So we just kind of showed you an example where it's all put together, but it could obviously be separated if need be. And again, then you can view what that system is doing best, and you can see how it's going to help your decision. Right?
Fantastic. Yeah, because I was just tying this back into my industry specifically for the civil engineering. I could apply this to something like in the past, I've had to do condition assessments of existing assets, whereby if I could now go and create the existing SCADA data that I already have, it would have freed up time for me to know what can I avoid and what information do I already have versus what do I still need to capture. So I think being able to leverage this, even just outside of a plant of operation, is still very, very big.
Yeah, definitely. I think we've gone on the days of, systems also operating in silos. It's all about data exchange, about interoperability, letting systems and products do best what they do, but how do we make sure they exchange that? Right? And because the asset doesn't move, well, sometimes it does, but most times it doesn't move. It's all bound to the same location, different descriptors about that location.
Yes.
That's where the power of something towards the operation and use of the geographical spatial reality helps you get a lot of benefit out of that. All right, so I think then on that point, let's open up to some Q&A. All right, so the first question, how can a design team start preparing to build digital twins? Right, so with that, I think definitely start with the audit, most times than not, an in-house audit to see what is not digitized, what is hard copy, what is soft copy. That's the first part. But there is a lot of structured, especially in, I think, the ISO 19650 as well, structured guides and ways that say, what are the building blocks? Even Esri has, from building digital twins, you can just search for that. What is the typical life cycle? Where do you start? Once you pass that point, what's point number 2?
Yes.
So online resource obviously going to help you a lot. But practically, if you are around, I would also say contact between Esri South Africa or Modena, because they can help you get to that answer a lot quicker. Because again, it's the context, right? What do you want this digital twin to do?
Yes.
So there's one way to build it, but what do you want to leverage from it? Because that could then steer the direction of that 10-step becomes a 5-step or becomes a 15-step, depending on what you want to do.
Yeah.
So hopefully that helps. Obviously, the online resource, I think, will just give you the concept and the practical understanding of what a digital twin
Correct.
Involves, but to operationalize that, just have the conversation, right? I think open the conversation there.
There we go. Yes. Just make sure that you have access. And what I'll just add to that is just make sure that you understand what is your deliverable, because that's going to be your main tie-in is when I'm handing this over, who's going to use it and what information do they need? So also start reaching out to the end users further down the process and start understanding what affects their day-to-day processes. And that will allow you to incorporate and plan for that ahead of time.
Yeah, no, definitely. All right. Well, hopefully that helps answer your question. And the second question, are the inspections tracked by staff automatically logged via mobile devices? Yes. So what I didn't show you a visual of, but when I did create a work order or inspection order, that would have gone if I assigned it to Jason. Sorry. Sonya's role reversed. Jason assigned it to me.
Yeah, we go. Yeah.
On my mobile device, I would have then seen it there. Right.
Okay.
From there, whether it's offline or online, that allows me to have the kind of smart form to then capture that information against. So it still requires me to actually open up what would have been equivalent of the hard copy form that I'm going to fill out. But now it's a step further because I can take photographs, proof of evidence of what is done. Not only maybe before that, leveraging in-house organizational information to help me resolve that. But yes, so once that is logged, if it was offline, once I get internet connectivity again or back in Wi-Fi zone, it'll push it back to the ArcGIS repository, and that's how the office sees a view of it. And with that, then there's what systematically is tracked is, was it me? What time? And obviously the status exchange. You can set up the workflow from, okay, it's now an open ticket to in progress. The moment I click submit, it's been resolved, right? Maybe it needs to be validated, etc.
Yeah, we need to sign off.
And that's what the organization will choose what is their standard of practice. But yes, hopefully that helps. Definitely from a mobile device, because we would want them to leverage their GPS actual
Yes.
On the device to get there, to navigate, etc. All right. Okay, let's go through the next question. All right, not sure if I'm maybe thinking of script, but the direction of digital twins seems like they will phase out the as-built stages as the fed models will forever be live and constantly getting updated for any changes.
Yes. So from my side, you're actually pretty much getting close to that. Yes. That is where we are moving into, because once again, our federated models allow us to do a multi-stage check within a project lifecycle. So whether that be for clash detection, metadata, such as materials or installation dates or stuff like that, the federated models allow us to start bringing in those questions of what am I missing. So you're perfectly correct in saying that technically as build stages will fall away, because the federated model should technically be first off our as built, and secondly that becomes the digital twin. So yes.
Yeah, definitely. All right, then maybe just confirmation there, just to echo what Gary's put in the chat. Thanks for that, Gary. So yes, to answer that question, InFocus Pro cannot simulate down spillway breaks. However, ICM can do that. InFocus ICM.
Correct. Yes. So ICM does have the capability, but once again, just coming back onto the non-Newtonian calculation specifically, that is one of the major limitations. So just keep that in mind.
Yeah, so I think just to round off from my side, maybe a more futuristic look, because obviously there's a lot of data, right? Let's not kid ourselves. There's a lot of good data, complete data that is needed to create these good, rich, embedded visuals, right? At the end of the day, we can see these nice visuals that have it kind of all pulled together, but we've got to make sure that data's in place. That's the fuel in the engine before you start to drive the car.
Yes, that's actually a good analogy.
So this is and there's not a lot of organizations, but this is how some organizations are starting to use that data, which is in a 3D state, a bit differently, right? So example with augmented reality or virtual reality, before you even go out and start looking for an asset or trenching, whatever the case is, to see, I mean, on screen, these are underground assets, right? So you can imagine at the office popping on goggles to contextualize yourself where you are with regards to the virtual reality of something, to where your asset is, and then strategically planning around that, right?
Yes.
We wanted to do a big infrastructure project here, but we can see this existing infrastructure. How are we going to work around it? Do we go to the left, to the right, et cetera, et cetera? Yeah, we'll maybe share this link afterwards, but this is also where the future is moving, right? So how do we create these rich digital realities, spatial realities, where we've embedded all of our data sets? It's not just a visual of the city, but you can see that they've kind of put where are all the assets. So from the BIM files to the actual infrastructure, whether it's roads, water, etc. They've created a nice way for people to get well orientated before a further decision is made, right? So you can see, they've actually got the BIM model. They switched over the view there, but it's in the same view. Right?
Yes.
You can then start doing some analysis. Maybe it was for valuations, right? You can think in USA, the higher you are on New York, the more you're going to pay for your property.
There we go.
Right?
Yes.
And etc. So even when was a building last inspected, maintained, again, those thematic images or patterns of green, red,
Yes.
right? It paints a different picture. So you can see it's just different ways of interacting with different data sets that most likely were there. But how do we just make sure it's spatially located so that it can be used? I think that's the key part. And I like sharing this specifically because I don't think that's always the end goal, but to realize whatever information you are the curator and creator of, if you can get it spatially located and make sure that component is there, right, it just really helps downstream. Because it has to fall into a greater context. It's never in a silo. It has a purpose within the greater context.
And putting it in the greater context, just looking at this, it blows my mind because I can already start answering questions that I had before I saw everything in context relative to one another. So just the amount of efficiency you gain from viewing everything, and I can see a possible answer to a question I have preemptively.
Yeah, exactly.
Oh, that looks fantastic. I mean, vehicle traffic simulations.
Yeah, they gamify it a little bit just to see.
But that once again, just I like that people are taking the chance and the time to do this because it does show you that it is possible. Going from a generic design all the way to rendering, it's possible.
Yeah.
We just need to have the time for that.
Yeah, 100%.
Fantastic. Great. All right. So yes, that is now the end of today's webinar. So just to get you guys some additional information, so you'll see in the blue box is our contact information. So whether you need to get contact for AEC or Esri South Africa directly, please feel free to contact us both. We're happy to have further discussions and anything technical. So, and then also please don't forget to give us some feedback. So the questionnaire QR code is on the screen. So please take a moment to scan that. And then, yes, we'll still be online for a few questions and answers if there are any. But Claudia, from my side, thank you so much for joining today. I think it was fantastic. I've saw a few cool things that I thought would be interesting to have a look at. So I'll definitely be asking you a few more questions from here.
Thank you. Thanks for having me.
Fantastic. So I don't see any questions so far. Thank you very much, everyone. Have a great day further.